tonight's talk is about women in astronomy, but my talk in July will be about Mars, especially focusing on the Perseverance rover. So the talk will uh, detail a little bit about what we know, just some general information about what we know about Mars, what we've been looking for the last few decades, and then what the Perseverance rover has been up to since it landed on February 18th. And so that should be pretty fun. So it's one of my favorite topics, and so hope you can join me for that one. And but this one is about women in astronomy. So I started doing this one a few years ago because people, especially libraries, had requested a topic about the history of women in astronomy as a science. And the more I looked into it, of course, I had heard of some of the names, but the more I give this talk, the more I realize most of the names that I'll mention tonight, people have never heard of. So I hope you enjoy hearing a bit about this. And in the beginning part of the talk, you'll hear me kind of flip back and forth as I'm giving names. It'll sound like I'm going toward a more general science person, maybe a more astronomy person. This whole focusing on astronomy, especially some subset of astronomy, is a relatively modern way of thinking about that science up until relatively recently. People may have focused on astronomy. They may, sorry, pun not intended, not intended. They might focus on astronomy. They might have dabbled in physics. They might have dabbled in optics. They might have done a little chemistry, or in the case of Isaac Newton, alchemy. So all of this was fair game. So at the beginning, I'll kind of go back and forth a bit. So anyway, why don't we get started? I'm going to go back to sharing my screen. All right. And Christina, just to let you know, as I'm doing this, my video window goes behind my PowerPoint. So if something happens and my video goes out, or all of a sudden something weird goes on, just jump in on the audio and let me know, because I won't be able to see if something goes wrong. So,
oh, no problem.
All right, so let's get started. All right. Now, until relatively recently, science as an endeavor, especially a job, was only available to certain people, and this was mostly men. In the 1500s, girls did not go to grammar schools. Upper class girls were taught by tutors. Two of Henry VIII's wives, Catherine of Aragon and Catherine Parr, did happen to be very well educated. Girls from well off families generally received their education at home. Sometimes this education was on par with that of boys at the time, but many times an education for girls involved what was deemed useful skills for women to aid them in their future family lives, such as dancing and needlework and music and cooking. Some women did learn to read and write. They might learn to speak one or more languages. Middle class girls may have been taught reading, writing, math, sewing, needlework. If you were a merchant's daughter, you may be lucky enough to have your father teach you to run the family business. Maybe he didn't have a son of his own to pass the business on to. Maybe a daughter was the only option. So some of these daughters did learn how to run a business. Some women got a really good education if they went into a nunnery. Or were involved with a monastery in some way. Some women were taught to read by their husbands. Maybe if they had a clergyman father, they were taught to read from them, maybe by a parish priest. Women could gain access to science through their families, their husbands, their brothers, um, maybe in a certain trade, but these examples were not necessarily the norm. Science remained mostly the area of men. So while I'm going to talk about several women who were involved in history, this was not par for the course. It was mostly the realm of men. Now, astronomy is one of several subjects that depends on a mass of observations. Sometimes astronomers and wives or other family members participated together because a team of two people may have been needed to make and record observations. If one was handling an instrument or a telescope, they wouldn't be able to handle that instrument or telescope and also record what was being observed, especially if this was out in the dark. Here's an example of a family member helping an astronomer. You may have heard of the astronomer Tycho Brahe. He was active in the late 1500s in documenting the positions of objects in the sky very accurately. This was prior to the invention of the telescope. The image on the left is a general image of Tycho and his observatory. And so what you'll notice is that he involved observing with very large instruments. Of course, one or more people might have been needed to handle the instruments. Again, someone else would be needed to record the observations. He had a sister named Sophia. When she was 17, she started assisting her brother with his observations. He expressed with great pride that she learned astronomy on her own. She studied books in German. For any books that weren't available in German, let's say they were in Latin, she used her own money to pay to get these books translated into German so she could also study those. Now, what Tycho was eventually well known for was his precise observations in the sky of the position of the planet Mars. His observations were then used by Johannes Kepler to show that the orbits of planets were oval shaped and not circular as was commonly thought at the time. Sophia played a part in recording observations that were later used to really advance the science of astronomy. Now, if you were a person of means, meaning you had money, you likely owned scientific instruments at home, maybe a telescope, maybe an astrolabe, maybe a sundial. Now, an astrolabe was a navigation and surveying tool. Sundial, of course, to tell time, maybe a telescope to be able to look at the sky. You owned and displayed these instruments to wow your friends and relatives. Maybe you actually used them as well. Basically that was sort of the Instagram of the time. So instead of taking photos of the things that you owned and you were showing off, you actually showed off the actual thing in your house. If you were a woman and there were science instruments in your home, you may have had access to those materials or not. It wasn't necessarily a given. In this image, we see Elizabeth Hevelius on the right. Elizabeth was the wife of Johannes Hevelius, and that is the gentleman on the left. And she became a valuable observing instrument to Johannes. Now, following Johannes's death in 1687, she completed and published Prodromus Astronomiae in 1690. This was a jointly compiled catalog of 1,564 stars and their precise positions in the sky. The images on the screen are of the Adler Planetarium's copy. The positions of the stars in this catalog were so precise that they were used to create celestial globes for several decades, and she was an important part of the construction and publishing of this catalog. Unfortunately, as far as we know, the first known professional female astronomer who would have been the first woman to receive money for her astronomy work as a regular salary or stipend is not recorded in any picture form, or if she was, images do not survive to this day. Her name was Christine Kirsch. She was born in 1696 and she was the daughter of astronomers. Christine and her sister were educated in astronomy from the age of 10, as was their brother Christfried, shown on the right. Their father, Gottfried, is the person on the left on this set of images. As a child, Christine assisted her parents in their astronomical observations. As we've heard, that sounded like kind of a common thing amongst folks who were looking up at the sky at the time. Later, she was instructed in calculating calendars. Now, this doesn't sound like anything terribly amazing these days. What do? You put some boxes on a page and you number them and you put a goofy picture of a cat up top and there you have your calendar. Well, back then calendars were a lot more complex. They had saints' feast days, moon phases, positions of major stars, positions of planets, and a lot of other astronomical information. Following the death of her brother, Christfried, the Berlin Academy of Sciences relied on Christine for calculating their complex calendars. The Academy had a monopoly on calendars and they generated significant income. She did eventually receive a salary from the Berlin Academy for her work, thus becoming possibly the world's first paid professional female astronomer. Unfortunately, we have no idea of what she may have looked like. In the 1700s, there was only one university that admitted women. This was the university in Bologna, Italy. Now, women in Italian states had been known to take degrees at university as early as the 1600s. But please note, while this was a long tradition, the number of women was still very small. In the 1730s, Laura Bassey earned her doctorate, and she worked as a university instructor, only the third woman to ever earn her doctorate, as far as we know. And she was recognized as the first woman in the world to earn a university chair in a scientific field of studies. She was admitted to the Bologna Academy of Sciences. She was a physicist. She conducted experiments on electricity. She published papers. All this, and she was married and she raised a family. My favorite part is her husband was her teaching assistant. Now, the image on the right, I need to explain it a little bit. First of all, if the image on your screen is small, then you may not be able to tell, but all of the people in the crowd, as far as I can tell, are men. And Laura is up on the dais on the raised platform there on the left-hand side of the image, and she's speaking to the crowd. Now, they are there for two reasons. Number one, the crowd is there to listen to her speak on some form of science. Number two, they are there for the sheer novelty of the fact that just going there to actually see a woman speak science, that was the novelty part. This was something odd and something you just didn't see every single day. And so she had a full crowd to hear her talk about whatever the science was and to just talk science at all. So anyway, she was quite a respected person. Although, side note, I wonder what were what was everyone's reaction? Did they actually respect her for her knowledge? Was it really more the novelty? I wish I knew more about that. So if you're interested in learning more about Laura Bassi, I encourage trying to find some resources that tell a little bit more about her life. Émilie du Chatelet was a French mathematician and physicist and author. In 1737, she published a paper entitled Dissertation about the Nature of the Propagation of Fire. And that's the image that's on the right-hand part of the screen here. This was based on her research into the science of fire itself. Her research predicted what is today known as infrared energy. You may know infrared energy as one form of it anyway, as what your skin detects is heat. And she predicted some aspects of the nature of light. Infrared energy was later discovered a few decades later by astronomer William Herschel. But his work is built on the theoretical work of Émilie du Chatelet. Also, if you're interested in learning more about Émilie du Chatelet, the Stuff You Missed in History Class podcast did a podcast about her specifically and her amazingly interesting life, her affair with Voltaire, and all sorts of things that we know about her. And they did this, I believe it was in January. So if you want to look up the Stuff You Missed in History Class podcast and look for approximately January of this year about their postings there, you will learn much more about Émilie. I highly recommend it. I really enjoyed it. Antoine Lavoisier, you might have heard of him. He was a nobleman and chemist in France in the mid to latter 1700s. He did many, many things that, little things like he recognized oxygen as an element. He named oxygen. He recognized and named hydrogen in 1783, small stuff. He did a little thing like, constructing the metric system. He wrote the first extensive list of elements. So he's known for some big time stuff in science, things we kind of take for granted these days, right? He insisted on very good measurements with very good instruments. Marianne Lavoisier was his wife. She worked with him. It's her writing that's in his notebooks. She created the detailed drawings of instruments for his book, and the drawing on the right is one of hers. Here's what I find most amazing. She learned English specifically to translate his scientific works from French to English so that they would be more widely disseminated in England at the time. Otherwise, if you were an English scientist and the only way you could access his work is if you spoke or read French. So this was her way of more widely disseminating his work. Um, she's not acknowledged in any of his books, uh, but throughout all this, uh, they did have letters from family visitors who did mention her. So at least we've got that. She had no university education. She did all of this without a university education. She was amazing. Now, one of my personal favorites is Carolyn Herschel. I mentioned her brother William just a few slides ago. William was her brother. William and Carolyn were originally from Germany and they then later moved to England. William was originally a musician and a composer, and she was a singer. While in England, he became obsessed with the science of astronomy, and Carolyn became his observing assistant. They lived together in a house before he got married. And so when he would do observations at night through the telescope, she would take notes on whatever it is that was being observed. While he slept during the day, she would do the data processing and calculations and clean the house and cook the meals and essentially take care of everything around the house. And William did all the astronomy stuff. William built her a telescope in 1795. And that's the image that you see on the right. She used it to discover a comet. She was the first woman to be recognized as discovering a comet. She discovered 8 of them in all. Eventually, she was admitted to the Royal Astronomical Society as an honorary member. I don't believe women were allowed to be regular full-time members at that point. After William Herschel discovered the planet Uranus, she received a government salary of £50 a year for her work. She maybe, I think it's hard to ever be able to tell, but she may be the first woman to hold a government position in England. They made a remarkable team. Now, this set of images is of her notebook, and the fuzzy thing in the center of the circles is her image or her drawing of the discovery of the comet that would be named for her. And discovering a comet gives you instant astronomical immortality. You forever have this name attached to a celestial thing, but also anyone who discovered a comet at this time went on speaking tours. They were very well known, so they were engaged as speakers out in the public. So Carolyn at that time could have been like me, only talking about her discoveries instead of me talking about her discoveries. Anyway, the lasting impact that William and Carolyn had on astronomy is this. They compiled vast catalogs of information and observations. This was done by others before them. I gave you the example of Johannes and Elizabeth Hevelius and their catalog. Where they stood out, though, is that they took the next step and used their own catalogs of information to try to figure out how some things in the universe worked. They were observers and they were theoreticians. They didn't get everything right, but they at least took that next step of taking their own masses of work and tried to shape it and figure out how things above them actually worked in the heavens. They together helped show that figuring out not just what was up there was important, but also how did that stuff work. That was also important. They were modern scientists. Here's another example. Maria Mitchell was born to Quaker parents in 1818. The Quaker tradition taught that both boys and girls should be educated, and she was tutored by her father and also received an education at local schools. She developed a love of astronomy from being taught by her father about surveying and navigation. By the age of 14, there were sailors who were coming to her to do some of the difficult calculations that were needed for navigation for their long whaling journeys. I'll say that again. By the age of 14, they had adult sailors coming to her to perform those necessary calculations that they needed to be successful on their whaling journeys. She and her father continued to conduct observations. Now, this next image is not what I'm first going to talk about. So this is an image later in her life. So this next part will make more sense if I tell you that that is not what I'm about to talk about next. I'll get to this image in just a second. But on October 1st of 1847, Maria was sweeping the sky from the roof of the Pacific National Bank on Main Street through her telescope, basically just moving the telescope back and forth to see what she could see. She spotted a small fuzzy object in her telescope that did not appear on her charts. And if you discover a fuzzy thing that doesn't appear on your charts, chances are it's a comet. And she actually did discover a comet. She achieved fame. She went on a speaking tour. She went to talk to folks about her discovery. She was widely sought after. In 1856, she traveled through the US and Europe. While she went to Europe, she visited Paris, and she went to the observatory in Paris. The director of the observatory reluctantly gave her a tour, but declined her request to see the telescopes in the observatory domes. He didn't think she could understand how they worked, as he was talking to a woman who had been doing surveying and navigational computations by the age of 14 and also had used her own equipment to discover a comet. You don't just do all that by accident. So yeah. Anyway, in 1865, she became professor of astronomy at the newly founded Vassar College, and thus became the United States' first professional female astronomer. This image on the screen is an image of her in the college's observatory. She is the person sitting in the chair on the left-hand side, and you can see the telescope above them. She was the only female faculty member at Vassar. And according to the original college handbook of rules at Vassar, female students weren't allowed outside past dark. Makes it kind of tough to use an observatory if you're not allowed outside past dark. You can chuckle at that one, but that was a typical rule that women had to subscribe to. But she was very well loved by her students, and I can imagine, I'm going to of course paraphrase, I don't know what she sounded like, I don't know how she spoke, but I can imagine she probably said something like, the heck with that, you're going to come use the observatory out past dark. Her students just absolutely loved her. But while she was there, her first 10 years, she earned less than half what a comparable male professor earned. While the other male professors were offered school-funded housing, this was common at the time, and also even into the 20th century, this was still a pretty common thing. She slept on a sofa in the corner of a space that at one part of the day would be a parlor and another part of the day would be a lecture room. That was her bedroom at night. When she was finally offered housing, it was in the coal storeroom of this building. This is the observatory. But throughout all this, she was a tireless advocate for the education of women. Here's a great example of that. In 1869, she led an all-female expedition to see a total solar eclipse. And a total solar eclipse is when the moon completely covers the sun. This is a picture, a set of two pictures from that expedition. She is the person sitting in the chair kind of in the middle of the picture, and one of her students is there on the left-hand side. And then the people, or the gentlemen arrayed around them, are dignitaries of the town of Burlington, Iowa. And you can see the telescope in the shed behind them. Now, why this is two images that look basically exactly the same. This is meant to go into an early stereo viewer where you would put these two images, you'd slide the card of images inside, and lenses on the inside would essentially bring the images together, and they would look like a single stereo image. So think of this as the original ViewMaster viewer. In 1878, she led another solar eclipse expedition to Denver, Colorado. And here's a picture of that. And what was rather amazing for the people of Denver, they came out to see where she and her students were. They saw them setting up the telescopes and taking their notes and doing their calculations and all that. But just like Laura Bassey, they were not only there to see the science, they were there to see the women doing science, because that was not something that you saw every single day of the week. And so people loved her. They came out and flocked to see her because, hey, they were kind of proud that she chose Denver to set up her expedition. So anyway, that's why I really enjoy talking about her. She did things quite a bit differently from the norm back in the mid to latter 1800s. Now, in the early 1900s, women were not allowed to operate professional telescopes. Indeed, the only women often allowed to set foot in observatory buildings were cooks and cleaners. Fast forwarding several decades, Palomar Observatory out in California did not allow women to use the facilities there in a professional manner until Vera Rubin broke the barrier there in 1963. 1963. How did Vera Rubin do it? Well, she was allowed in, but they were saying, "Oh, we're so sorry. There are no bathroom facilities for you here. This just isn't going to work." And she went, "Oh, really?" And she took a piece of paper and she cut out a paper doll with a dress on it and she slapped it up on the door of the bathroom and she said, "Now you have facilities for women." So anyway, I can very much respect that. Princeton University did not even accept women as astronomy graduate students until 1975. So I'm going to guess there are people for 1975 is probably within your lifetime, right? Within the lifetime of some of the folks watching this program. That's when Princeton University started accepting women as astronomy graduate students. All right, going back to the early 20th century. At the time, women instead were mostly hired as computers. Now, we think of the word computer meaning a machine that computes. Back then, it was a person who computed. And what they were doing was analyzing and compiling data from telescopes. Computers at the Harvard College Observatory were women, and one of these computers was Henrietta Swann Levitt. Her work involved categorizing stars that varied in brightness. Now, I'm going to greatly condense the science of what she found out, but what she is known for is fundamental to figuring out the structure of the universe. What she did was, again, very much condensing this, and if you want me to talk about it in a little more detail, I can at the end. Basically, if you figure out how long it takes a star to vary in brightness, and some of them do, a lot of them don't, but some stars vary in brightness. They don't all vary at the same rate. And stars that took a shorter time to vary were dimmer. Stars that took a longer time to vary were brighter. If you could figure out how long it took the star to get brighter and dimmer, essentially you could figure out how far away that star was. And if that star was in and amongst other stars in a group, you now knew how far away the group was. Or you knew how far away a gas cloud was because it might have been a star as part of that. So anyway, this was an amazing discovery. In fact, by discovering a variable star in the object known at the time as the Great Nebula in Andromeda, Edwin Hubble used the relationship built on Henrietta Swann Leavitt's work to show that the Great Nebula in Andromeda was actually a separate galaxy. We use the word galaxy now, far from our own. Now, this is a version of the image that he worked with, and you can see this was on the 6th of October of 1923. And he has highlighted 3 stars on this photograph, and he initially highlighted them all with the letter N. The word N meant nova, and in Latin the word nova means new, and all it meant was this star for some reason got brighter and dimmer, and that's it. But then he realized that this particular one, no, it didn't just get brighter and dimmer once. it got brighter and dimmer repeatedly. And he went, oh, wait, no, not a nova. This is VAR, variable. He was very excited and added an exclamation point. But he was able to figure out that this was a star amongst this galaxy group. And he figured out how far away. He was able to say that this thing is separate from our own Milky Way galaxy. So this has become one of the fundamental methods of calculating distance in the universe. It's not the only way we have now, but it is one of the fundamental ways. So amazing work by Henrietta Swann Levitt. Another of these computers at Harvard was Annie Jump Cannon. She studied physics and astronomy, and she graduated with a degree in physics in 1884. Because there were limited opportunities available to women in the career she was interested in, she returned home to Delaware for about 10 years. Now, during these years, she developed her skills in photography. And in 1892, she went to Europe, taking her Blair box camera with her. And she took a lot of photographs, took a lot of notes. And after she returned home, her writing and her photos from Spain were published in a pamphlet called In the Footsteps of Columbus by the Blair Company, the maker of her camera. And this pamphlet was distributed as a souvenir at the Chicago World's Columbian Exposition of 1893. And the image on the right is her image of the Mosque of Cordoba in Spain. Now, Annie and others with her worked with about 500,000 glass plate images from observatories around the world. This is an example of one of them, and I'll explain what this is. Basically, if you have an image of something that has stars in it, you're going to see those stars as little pinpoints. Let's say you have a way to essentially spread out the light from the stars. You want to see what patterns you can see in the light. Take a look at all the little strips on this page or on this image. You can see that not all the strips look exactly the same. Some of the strips are different. So if you take a look at, say, this pattern here, it looks a little bit different than that one or this one here. You see some bright and dark areas, but it's not the same. The bright and dark areas aren't necessarily patterned the same. And she saw this. She noticed similarities between the patterns from different stars on these glass plate images. And she grouped the similar ones together in letters designations. One group she gave the letter A. Another group she called B, and so on. And then she noticed even within those letter designations, there were individual differences in between. And so there were 10 designations for A, there were 10 designations for B, A0, A1, A2, and so on, all based on the individual little strips of dark and light in the pattern of light that we saw from these stars. Subsequently, some of the letters were dropped. They reordered several of these letters. This classification system for stars is now known as OBAFGKM. Okay, first off, she did this herself by memory for 300,000 of these strips of these images of the pattern of light from stars herself, again from memory. It wasn't like she was working with a library of these images and she kind of flipped through and went, oh, that one's an A0. Oh yeah, that A0, it matches that A0 here. She did it all by memory. 300,000 of these glass plate patterns. Now, what did these patterns mean? She didn't know that, but she was able to group all these together. And then the next step was, what does it mean? Now, in these classifications, blue stars are O stars, red stars are M stars, our sun is a G-type star. Take a look at the patterns, and I don't even have to get into what the differences are because we didn't know what the differences were. Notice that the O stars, you don't see a lot of the dark lines within that set of patterns. But in the B line, hey, some of these dark lines are starting to come out a little bit more. And in the A line, they're even darker. Look in the F line, there's this line right here that didn't appear on any of the others, or at least it was pretty faint. You can kind of see it's a really faint version here. and then maybe this line right here comes out a little bit more, and so on and so on. Now again, why did these patterns exist? It wasn't just color. What was color telling us? What were these patterns telling us? We'll come back to that in just a second. Now, Annie and Henrietta and the other lady computers employed by Harvard worked 6 days a week for 25 cents an hour, doing these various classifications and other work with all this data. 25 cents an hour was more than a factory worker earned, but less than a clerical worker. Now, these women were definitely hired for their skill, and they were fantastic at what they did. The honest truth was, women weren't paid as much as men were, so more women could be hired for the same budget. They would have had to pay men more. Their efforts paved the way, though, for women who would work in computing and aerospace industries and engineering as human computers, because the men that these women worked for tended to give them credit for the work they did. They appeared at conferences. Their names are on scientific papers. Side note, we have a couple of images at the Adler Planetarium in the archives of Annie Jump Cannon at the Adler. In 1930, she visited as part of the American Astronomical Society meeting that was in Chicago that year. And so we have a picture of Annie Jump Cannon inside our building, sitting in a chair. It might have, I don't know if it was a party or anything, but she was sitting there looking at the camera. There's another image of her on the roof of the Adler as the director of the Adler at the time, Philip Fox, was showing off. It's essentially a special kind of solar telescope. He was showing off this new solar telescope to an assembled crowd of astronomers, and she was one of them. What I love about that picture is, I don't have it here, but what I love about it is she's the only one staring directly at the camera. So I tend to think you can kind of get a sense of what she's like by that directness. I like to think she was a direct person. Anyway, so she did appear at these scientific conferences. Now, it's not that everything was all fun and games. She was one of very few women who appeared at these scientific conferences, but she did get credit for her work. Now, getting back to what did those patterns tell us? Cecilia Payne, later Cecilia Payne Gaposchkin, figured that out. She was born in England, and her father died when she was 4. Her mother faced raising the family on her own. In 1919, she won a scholarship to Cambridge, and she studied botany, physics, and chemistry. But while she was there, she heard a lecture by a famous astronomer, Arthur Eddington. And so this lecture sparked her interest in astronomy. She completed her studies at Cambridge. However, she was not awarded a degree because of her sex. Cambridge did not grant degrees to women until 1948. It's not like she didn't do the work. She just was not allowed to get the piece of paper that said that she was able to do the work. Whoops, sorry. I just went forward a little bit. Sorry about that. She realized that her only career option was going to be to have to move to the United States. And so she got a grant that would enable her to move here. And she started working with Harlow Shapley, who was the director of the Harvard College Observatory. She was persuaded by Shapley to write a dissertation. And so in 1925, she became the first person to earn a PhD in astronomy from Radcliffe College, which is now part of Harvard. And there were several people who later called her thesis, quote, undoubtedly the most brilliant PhD thesis ever written in astronomy. So what was this brilliant PhD thesis? She figured out what the lines in those stellar spectra were telling us. The variation in the pattern of lines was due to a range of temperatures of stars. She also established that hydrogen was the overwhelming constituent of these stars and thus was the most abundant element in the entire universe. She showed that Annie Jump Cannon's ordering of the stars by that letter and number designation was a sequence of decreasing star temperatures. She was able to calculate these temperatures. Think of all that contained in one thesis. And this is, again, fundamental to our understanding of stars. if you want to know, how do we know what stuff is made of out there? Because we can't go to it and pick up pieces of stars and bring them back. It's because we have the information coming from the light that comes to us from those stars. And the patterns of light tell us information, what the stars are made of, how much of it is there, and also what the temperature of these stars is. Now, when her dissertation was reviewed, astronomer Henry Norris Russell dissuaded her from presenting these conclusions that the composition of the sun was made mostly of hydrogen, because this did not jive with what was accepted at the time. However, 4 years later, when he derived the same result by different means, he published that and got credit for it. He acknowledged her work briefly in his paper, but he was often given credit for this discovery, um, even after Cecilia had been proven correct. Um, so she has been, in the last several decades, been getting that notoriety, that positive notoriety of being the person who really did discover all of this. So anyway, it's nice to know that, again, another aspect of fundamental to astronomy work here is getting the credit it deserves. Wasn't the case at the beginning, but anyway, we're getting there. Now, the first woman to work at what was known at the time as Langley Memorial Aeronautical Laboratory, this was later NASA's Langley Research Center, was Pearl Young. This is the lady in the picture here. She started working at Langley in 1922, and she was an engineer. And she eventually became the chief technical editor for the National Advisory Committee for Aeronautics. This is sometimes abbreviated NACA or NACA. NACA was the precursor to NASA. In 1935, NACA hired 5 women to be among their computer pool, so women to be computers at Langley. One NASA historian has said, quote, "The women were meticulous and accurate, and they didn't have to pay them very much." Where have we heard this before? In June 1941, as the Second World War was raging over in Europe, President Franklin Roosevelt uh, issued Executive Order 8802, which banned discrimination in the employment of workers in defense industries or government because of, quote, race, creed, color, or national origin. Did I say gender? No, I did not, because that was not included. 6 months later, after the attack on Pearl Harbor, NACA and Langley began recruiting African American women with college degrees to also work as human computers. They did the same work as their white counterparts, but the African American computers had the added disadvantage of being paid less, and they were relegated to the segregated west section of the Langley campus. They had to use separate dining facilities and separate bathroom facilities. What was even worse, I mean, granted, all of that is horrific, and this is just terrible icing on the cake. Despite having the same education as their white women counterparts, they were forced to retake college courses they had already passed. Remember, these were college graduates also. They already passed these classes. They had to take them again, just to prove again that they actually knew what they knew. So they were often never considered for promotions. They were often never considered for other jobs at NACA. So the color of their skin determined they had to even prove themselves to an even higher degree than the other white women had to do at that time. Now, Katherine Johnson you may have heard of her. She is one of the women featured in Hidden Figures. She came from a small town in West Virginia. She graduated from high school at the age of 14. She graduated from college at the age of 18. In 1953, she was hired by NACA, and 5 years later, NACA became NASA, thanks to the Space Act of 1958. Her first big NASA assignment was computing the spacecraft trajectories for Alan Shepard's historic first American spaceflight in 1961. Her and her team's job was to trace out in minute detail exactly where the spacecraft would go from liftoff to splashdown. Now, her main job in the lead up to and during John Glenn's historic orbital flight was to double check and reverse engineer what the machine, the IBM computer, was giving the team for trajectory calculations. So this new machine was out there, but not everybody trusted it, including John Glenn. And so basically the machine was fed the calculations and it spat out a number. They had to then take the result and reverse engineer all the calculations to arrive at the initial set of information to make sure that what the computer was fed and what they figured out was the same. Because they didn't, a lot of the folks did not trust the machine yet. Just think about that. These days, we take whatever the computer spits out pretty much for granted, right? You do something, and you don't even think that the computer might not be showing you the correct thing. But that wasn't the case at the time because these were still very new machines. Anyway. I mentioned John Glenn did not completely trust the computer. During his mission, it was touch and go because there were problems with the spacecraft. And so they had to make sure that his reentry path and reentry point was right. And so he asked the head engineers to, quote, get the girl, Katherine Johnson, to check the numbers. If she says the numbers are good, I'm ready to go. So what he was saying was, I don't trust the machine. I trust Katherine Johnson. If she says it's okay, then I'm okay. Now, Katherine Johnson would go on to work on the Apollo program too, including performing trajectory calculations for the 1969 moon landing. She retired from NASA in 1986, and in 2015, President Obama awarded her the Presidential Medal of Freedom. She liked to say that she was just doing her job and, quote, it was just another day's work. If you want to learn about more women, I highly recommend taking a picture, a screenshot of this slide. And if I go to the next slide and you haven't done that yet, and you want me to do that at the end, I can go back to this slide. But anyway, look up for any biographies or any autobiographies from any of the women on this slide. Very interesting folks. I'll get to a mention of Nancy Grace Roman and Vera Rubin in just a second. But one thing that I know is well, at least in the before times, it was common sometimes to have scientists visit classrooms. Maybe you're a teacher and you want a scientist to visit your classroom. Maybe you might do an advanced activity, and you might have your students imagine and draw. What does a scientist look like? And I'm going to have you do that in your heads right now. I just gave you that question. What does a scientist look like? And I want to, you don't need to put this in the chat or anything. Raise your hand mentally if you initially thought a scientist was a man. Raise your hand mentally if you initially thought a scientist was a man with crazy hair, or you thought the scientist was a man with an old man with crazy hair and a lab coat. So basically, how many of you thought Albert Einstein, right? So this is these are unconscious biases that we're a lot of times not even aware of, that we need to get ourselves away from. Scientists, this is what scientists look like. Scientists are scientists are everybody. We're all scientists, but there are women scientists out there too. We're not all white men, right? We don't have crazy hair and lab coats. Well, there are some that have lab coats, but not everybody, especially not in astronomy. But people ask a lot. So what is it like today? What are we in today? I've given you some stories of the hardships that women had to overcome. They were paid less, they were respected less. Sometimes their research was stolen from them. Sometimes they did get credit. Sometimes they had to sleep in a converted coal storeroom. Sometimes they didn't get even the ability to prove what they were able to do because people just didn't trust them, or they had to reprove what they had already learned. So what is it like today? What are we looking at? So this is a set of charts, and this is it's going to be hard to parse this out. I'm going to summarize this chart. Basically, this is the number of women in astronomy, female astronomers, and which rank of professor or not that they were in 1992, 99, 2003, and 2013. If you add up all the numbers in each of these years, the number of women in astronomy is going up. Also, the number of women being represented at the full professor level is going up. So that's good. The problem is it's still a very small number of the overall number of people earning astronomy degrees. And it's so the numbers are going up, but it's not as though the number of women is approaching the number or the percentage that women are in the US population, for example. Women make up about 51% of this country. Women make up less than half of that, of the number of university positions in astronomy. That's unfortunate. Some unfortunate news is that the universities that are out there making a concerted effort to retain and hire women are doing great, but the ones who are not making that effort are not retaining women. They're not going to work there. And so university departments are getting more polarized in terms of, if you are actually trying to retain women, you're doing it. If you're not actually trying, you're not. And so it's the other unfortunate thing is that the highest ranked institutions have been slower to recruit, promote, and retain women than mid to lower ranked institutions. I want to give you another example of that unconscious bias. Oh, sorry, one more slide about these numbers. We have a really long way to go in terms of the number of Black, Indigenous, and people of color who are women who are Black, Indigenous, people of color who are going into astronomy. It makes up about 6% of the total. That is woefully inadequate, way under the percentage of the population overall that uh, we have a long way to go to get those numbers up. And we're not just going to do it by, you go, okay, we need to get more girls involved in science. That alone is not enough, because it has taken decades to get us to this point, and we have many more decades left to go if we just try to let this happen naturally. So we have to make those concerted efforts. But I do want to show you another example of unconscious bias. And you may not even be aware of it, but I want you to start looking for it. And I know you can't read what's on the screen, especially if you're looking on your phone, but that's the point. What I don't need you to actually look and see what this is. I want you to know that the person on the left is a woman scientist. The person on the right is a male scientist. These are their Wikipedia bio panels. So when you go on a Wikipedia page, and you look on the right-hand side, if it's a person, especially a famous person, they'll kind of have a summary of their career there on the right-hand side of the page in a column form. The person on the right, you might be able to tell that's Albert Einstein, right? So who he worked for, things he's known for, discoveries, all that. Notice the length of Albert Einstein's Wikipedia bio panel. Albert Einstein won one Nobel Prize, very cool. Did a lot of stuff. He's kind of your prototypical scientist. When you think of scientist, that's who you think of. The person on the right, or sorry, on the left, is Marie Curie. She won 2 Nobel Prizes. And look at the length of her Wikipedia bio panel. Surely there is more information that could be added to her bio panel. Also, notice what's after citizenship. It is spouse and children. For Albert Einstein, children is spouse and children are at the end of the bio panel. Not saying spouse and children aren't important. It's that apparently for a woman scientist, we need to put the spouse and the children right up there near the top. Anyway, there's no right or wrong for doing that, but it's very interesting that it's not consistent. And that's the point. This is kind of that unconscious bias that we may not even, there probably aren't aware of. I'm going to give you some book recommendations. The Glass Universe by Dava Sobel, and this is about the Harvard College computers. Really good book. Hidden Figures, of course, the book by Margot Lee Shetterly about the Black women rocket computers in the 50s and 60s. And if you only saw the movie, please pick up the book and give it a good read, because there's even more detail in there than you could ever possibly put in a 2-hour movie. And then Discoverers of the Universe about William and Carolyn Herschel. So that is really good. Also, I'm going to put this link in the chat in just a second. This is a free PDF download about Nancy Grace Roman. This is a PDF of her memoir. And so you may say, oh, who's Nancy Grace Roman? Well, without her, the Hubble Space Telescope would not exist. She was the person who essentially made sure she was NASA's first chief astronomer. And she made sure that the Hubble Space Telescope actually happened. There are many times that it could possibly have been canceled in the 60s and 70s, and she dragged that program kicking and screaming into space, essentially. So I would highly recommend reading about her. I see there's a few questions, and I'll get to that in just a second. I just want to read you one little bit from the April issue of Astronomy magazine. If the library has this and you're able to check it out or read it at some point, please do. And so notice at the top, 2 new scopes honor astronomers Vera Rubin and Nancy Roman. So you can learn about the telescopes that are going to have their names on them, and also learn about them as well and what they are famous for in astronomy. So I just want to give you a little background about some of the stuff that you'll read in this article. And I was amazed that this level of detail was actually in this article, because this is the first time I've ever seen in a major publication like this, a public publication, that this kind of stuff was actually in there. Quote, Roman, meanwhile, graduated from Swarthmore in 1946 and went to the University of Chicago to earn a PhD. When she first met the professor who would become her thesis advisor, William Morgan, he told her to go to his house to change the bed since his wife was sick. Stunned, she complied. Roman soon discovered that most of the professors considered educating women a waste of time, since they were all destined to marry and become homemakers. Morgan rarely met with her and went 6 months without acknowledging the simplest greeting, Roman wrote. He was willing, on the other hand, to abscond with her research and present it as his own at a prestigious Vatican conference. On the night before her final oral exam, that's for her PhD, Morgan agreed to meet, but scheduled their session at midnight. Quote, he decided to use it as an occasion for petting, she wrote. I moved his hand several times trying to go on with our conversation. After earning her PhD in 1949, Roman stayed on at Yerkes Observatory another 6 years as a researcher and instructor, but with much lower pay than her male colleagues. The department chairman, Nobel laureate Subramanian Chandrasekhar, explained to her, quote, we don't discriminate against women. We can just get them for less. So that's just a taste of some of the information that's in that article. I was amazed, pleasantly amazed to see this. I will tell you, and this is my own personal recollection of going to the Yerkes Observatory and visiting there a few times. There's the William Morgan office. I had no idea till this article that Nancy Roman Grace ever graced the halls at Yerkes Observatory. There was this focus on, here's the spot that Albert Einstein stood on the floor next to the telescope, and here you can stand on that spot too. How about the woman who actually got the Hubble Space Telescope into space, essentially, made sure that program happened? No mention of her whatsoever. So hopefully that sort of thing will change in the future. So let's get to the questions. Who was the first woman to earn a doctorate? I have absolutely no idea. That's a great question.
I actually looked this up. Can I answer for us?
Thank you. Yes, please do, because you probably knew, like, Michelle's not going to know that off the top of her head.
All right. So I found this on scientificwomen.net, which I will put into the chat so you can take a look at some articles about scientific women. Scientific women. I spelled it right. All right. So her name was Elena Lucrezia Coronaro Piscopia, and she was an Italian philosopher of noble descent, first to receive an academic degree from a university in 1678. Apparently, she first went for theology, and they didn't allow that, so she had to get a doctorate of philosophy.
Wow.
Yeah.
We don't trust you with the religion stuff. So here you can talk
No.
about the fuzzy way life works kind of stuff.
Right. Yeah.
Wow. That's cool. All right. So why the random letter choices instead of A, B, C, D, E, and so on? So that's referring to the pattern of lines from stars. And actually, they originally were A, B, C, D, and so on. So Annie Jump Cannon had ordered them as A, B, C. But as she was getting through more of these, she noticed, oh, wait, there is an order to this. And I can put them in some order. But in order to do that, I have to rearrange the letters. So she basically, I think, I don't know this. She may have just said, okay, this one right here, I'm going to start with as A. And this other one here, I'm going to start as B. And then started noticing the relationships between the sets, and then realized she had to reorder the sets. And in astronomy, we have this really annoying way of doing things. We never go back and switch things around. I'm trying to come up with an example. Like a black hole is not a hole, but it's not like we've come up with a better name in the last few decades. So we sometimes name things and then figure out what they are. And then we don't go back and change the name, even though that first name isn't very descriptive or very good. Here's an example. There's an object out there, a type of object called a planetary nebula. Nebula just means fuzzy thing. And planetary, like it's round shaped like a planet. Does it have anything to do with planets? Nothing. Zero to do with planets. It has to do with how it looks, not what it is. But did we ever go back and change the name? No. We just keep you confused like that. So did they ever go back and reorder the letters and A, B, C, D, and whatever? No. I'm gonna guess, and I really don't know this, but I'm gonna guess that maybe Annie had written some papers along the way and figured out A, B, C, and so on. And then along the way wrote another one that said, oh, wait, I need to switch these. And so it's already out there in the literature. So you've already assigned a convention to it. You got to stick with it. So that's my guess as to how that worked. So.
That makes sense to me. I was just going to say there's probably already something out there that you can't go back and correct. So you have to just keep going forward.
Exactly. Yeah. That definitely happens. It sounds annoying at this point because you go, but wait, why? But we're also used to our alphabet. What makes using our alphabet any better than any other alphabet? So you might as well just keep it all the jumble. And actually, in astronomy, we tend to assign mnemonics to stuff. So the planets in order in the solar system. My very elegant mother just served us 9 pizzas. If you want to include Pluto, which I do. And OBAFGKM, OB a fine, well, sorry, this one is not the PC version. OB a fine girl or guy, kiss me, is how we learned it in school. I wouldn't necessarily go with using that mnemonic anymore, but that's a lot of times. So they'll turn it into a mnemonic. I'm sure someone will come up with something better than that. Then Pluto is still a planet. It's one of the comments. So there is no treaty out there that says you have to not call Pluto a planet. Pluto is, according to the International Astronomical Union, which is a subset of astronomers in the world, not all, some. There are 3 parts to the planet definition. Pluto meets the first and the second parts. It's round and orbits the sun. According to the definition, the third part is a planet must be massive enough to have enough gravity to clear out its orbit of other stuff. Okay, cool, confusing, but all right. Then by that definition, if we followed that definition, if you stuck Earth where Pluto is now, Pluto would not, or Earth would not fit that definition. It's not a good definition. It does meet the first two parts of the definition, so the International Astronomical Union calls it a dwarf planet. Round, orbits the sun. But again, not all astronomers subscribe to that definition. Not all of astronomers use it. Not all of them like it. And so there's a whole bunch of astronomers out there who still consider Pluto a planet. So this group says it's a dwarf planet. Not everybody says it is. I still think of it as a planet. I think they should have just stopped with round and orbits the sun. What's wrong with that?
Right.
And the argument that I heard, I don't know if this is true, but the argument that I heard was, oh, people have to memorize 15 things. And
Yeah.
so what? Who cares? We've already memorized 9. What's 6 more? So anyway, so oh, I love the comment from Bob. It shouldn't be so difficult to determine what a planet is when you're watching a science fiction show like Star Trek and they show up at some object in space and turn on the viewfinder. The audience and the people in the show know immediately whether it's a planet or a star or a comet or an asteroid. And that is apparently attributed to Alan Stern, who is one of the scientists who does not think Pluto is a dwarf planet. He thinks it should be a planet. But yeah. What are all the planets they go to? They're around and they orbit their star.
Mm-hmm.
We're not following that definition when we're naming planets in other solar systems.
Oh.
So there you go.
Well, we love Pluto.
We do, especially since there is a tie to Illinois, because the discoverer, Clyde Tombaugh, was from Streator. So he wasn't in Illinois when he made the discovery, but that's okay. We'll claim him.
Yeah, we'll take it.
All right. Any other questions, comments, concerns, anything else before we sign off?
Well, I'm just going to ask a dumb question. If you're an astronaut, do you have to have studied astronomy?
Oh, absolutely not. No. Ask me if you work at the Adler Planetarium if you need to study astronomy. Absolutely not. Everybody walks in thinking everybody who works there is an astronomer, and not everybody is. Actually, if I think about it, we have 1, 2, 3, 4, 5. 5, and if you count me, 6 astronomers at the Adler. And there are 78, 76 people who work at the Adler currently. So there you go. So yeah, no, you do not have to study astronomy to be an astronaut. They want you to have studied some science. There are medical doctors who've become astronauts. There are engineers, biologists, all sorts of stuff. They just don't want people who are afraid of science.
There you go. You gotta have courage.
Exactly. Same thing at the Adler. We just don't want people who are afraid of science. We want you to come and embrace it and embrace the mess. That's what this is. Science is a mess and we like it. So anyway, I say mess with all love and affection. So.
All right. Well, thank you so much, Michelle. And for everybody who's still with us, remember that she will be back on July 12th, roving the red planet. So we'll get some updates on Mars.
Exactly. And quick update, by the way, keep an eye out in the news. You may have heard that the Perseverance rover has a carry-along helicopter, and it's called Ingenuity. The first test flight for Ingenuity is supposed to be NASA likes doing dates as no earlier than April 8th. So next week could be the first flight of Ingenuity. So keep an eye out for potential images or video from that flight if they actually attempt it on April 8th or a few days after. So keep an eye out. That's coming.
Woo, thank you. So cool. All right. Thanks, everybody. Bye-bye.
Bye-bye.